Hello and welcome. So today's lesson is really helping you with the assignment that is called Not as Complex as You Might Imagine. And so this assignment, if you were to look it over, it looks really long and it looks a little confusing, but I think we can make it very simple, and I'm going to give you some hints and tips on how to do it, and hopefully review some concepts that you learned towards the end of Algebra 1, hopefully. If not, they may be new to you, and if that's the case, that's okay. So we're going to learn some new things, maybe, or maybe you've already learned them. So let's find out what you know and what you need to know for this assignment. So the first thing that you want to note is towards the bottom of the first page of your assignment, it says the 12 cards are divided into 3 groups. Okay, those with 2 real solutions, those with 1 real solution, and those with no real solutions. Okay, but with no real solutions, you're probably going to have 2 imaginary solutions instead. All right, you're going to want a partner for this assignment. So you're going to want to find someone in the class that you can partner up with. If we've got an odd number, then we can have a group of 3, and that's fine. Have partners work together, sorting cards into 3 different groups. Okay? When the work has been checked, direct them to begin the exploration. Lead the class in a group discussion to summarize findings, and finally allow students to complete the practice problem set. So we're doing all of that right here on this video. So right now we've got a set of 12 cards. Okay. So if you look at your set of 12, the top left corner, there's the letter I, and it is y equals x squared plus 3x plus 2. And then to the right of that is letter O, and that is y equals 2x squared plus 5x plus 4. Okay? And there's a total of 12 of them, 6 on each side. Okay? 6 in the left column and 6 on the right column. And you want to take those and identify which ones of those have 1 solution, which ones have 2 solutions, and which ones have no real solutions, but they would have 2 imaginary solutions. Okay? So I would like you to try it, and you and your partner can work it out as best you can. If you get stuck, that's okay, but I want you to give it a shot. See if you can figure these out. Well, I will actually do a few problems like them right now so that you can see how to do it. Alright, here we have a fairly simple quadratic. We've got y equals x squared plus 5x plus 6. Okay. So we can tell whether or not this equation that I've made up has 1 solution, 2 solutions, or no solutions. So there's a few different methods of figuring this out. One of them is to factor the right-hand side of the equation. So factoring is most simply done using the AC method. It's the method that I teach all of my Algebra 1 students. It's really the go-to method. There's other methods out there. The box method you may have learned, and other methods, but the AC method is really kind of the go-to method, at least in my mind. Most students find this to be the easiest way to factor. So we're going to do the AC method. So the AC method, we just take the A, which is the first term in front of x squared, times the C, which is the last term which has no x attached to it. We're going to figure out what that equals. And then we're also going to take B and see what that equals. So that's the first step. B is the number in front of x. Okay? So if you think about it, all quadratics could be written in the form ax squared plus bx plus c. Okay? And a is just the number in front of x squared, b is the number in front of x, and c is the number that has no x in front of it. Okay? So the a is actually just 1. Since there are no numbers in front of x squared, it must be 1. Okay? 1 times x squared is x squared. C is 6, so 1 times 6. And B is 5. Okay? So this is the AC method. So we can simplify this to be just 6 and simplify this to just be 5. There's nothing we had to do for B. So what two numbers both multiply to give you 6 and add up to 5? Okay. And so we can start making a list. 1 times 6 and 2 times 3. And then of course, if it mattered, you could do the opposite. So -1 times -6 and -2 times -3. So those are the 4 options that we have. There aren't any other whole numbers that multiply to give you 6 than these. Okay, so we want to check it. So we'd say 1 plus 6, does that equal 5? And the answer is no, so this one doesn't work. Okay, 2 times 3 is 6, is 2 plus 3, 5? And the answer is yes, 2 plus 3 is 5, so it works. And in fact, there's always a unique set that will be true for this. You'll never get more than one answer, so as soon as you hit the right answer, you know the other ones are not going to work. -1 plus -6 is -7, and -2 plus -3 is -5. So we know that there's only one answer because there's always just one unique solution to this problem. There's either going to be one unique solution or no solutions. Those are your options here. Okay? So 2 times 3 is 6, and 2 plus 3 is 5. So here we're going to get it done. Y equals, and we're multiplying them together. And the first term is x squared, so x and x. And then we've got a 2 and a 3. And they were both positive, so they're adding. So this is the factored form. X plus 2 times x plus 3 equals x squared plus 5x plus 6. Let's see if it's true. It's always worth it to check, even though I would say we don't have to. We know we did it right. You can check it. So this is a check method to make sure that you got the right answer. So when I'm going and grading someone that has factored, this is how I know whether or not you did it right, is I check it. And you can then check your own work. So all we have to do is multiply it out. All right? X times x makes x squared. And we're doing the FOIL method here. First, outside, inside, last. X times 3 is 3x. 2 times x is 2x. And 2 times 3 is 6. Okay. That's just the FOIL method. First outside, inside, last. Take the two middle terms, they combine to give us 5x. 3x plus 2x is 5x. Bring the 6 down, and bring the x squared down. X squared plus 5x plus 6, that's what we started with, so we are certain that we did it right. So, what are the solutions to this problem? Well, I think the first thing we want to know is what is a solution to a quadratic. So if you don't remember what a solution is, another name is a zero. So the zeros to the equation. That means when y is 0, what does x equal? We can solve this equation here because there's only one unknown. We could multiply it back out and have 0 equals x squared plus 5x plus 6, but there's no real nice way of solving it unless it's in factored form. And so the next thing that I think we should remember is if a times b equals 0, then either a equals 0 or b equals 0. Okay? So this is the zero product property. It states that if you've got two numbers being multiplied together and they equal 0, then either the first term is 0 or the second term must be 0. So in this case, a times b equals 0, we've got a, x plus 2, times b, x plus 3, equals 0. So either x plus 2 equals 0 or x plus 3 equals 0. That must be true. Okay? So either x plus 2 equals 0 or x plus 3 equals 0. One or both of these must be true. So we're going to subtract 2 from both sides to get x by itself, and x must equal -2, or subtract 3 from both sides, x must equal -3. Okay? Those are two solutions. So in this case, if this was one of our tiles, we would say that this has two solutions. And there are two real solutions here, -2 and -3. Those are our two solutions that we got. Okay? So -2 and -3, there are 2 points on the graph. Remember, y was 0, so these are points. -2 comma 0 or -3 comma 0. So there are 2 points that this curve goes through. And this is a parabola. And so this parabola either faces up or faces down. And we want to figure that out sometimes. In this case, we don't care. All we cared about were the zeros. But you can see that between -2 and -3 is -2.5. That is actually going to be the vertex. So we could actually plug those numbers in. So I'll do that just to show. But really, we're done. This is all you have to do for this problem, is find the zeros and the two solutions. Okay? So 6.25 minus 12.5, that actually leaves us with 6.25 negative 6.25 plus 6. Negative 6.25 plus 6 is negative 0.25. So we end up with negative 2.5 and then negative 0.25. So if we go left 2.5, we would go down 0.25. So not even 1, it's a quarter of a full movement. And there you go. That is our parabola. Not that that really matters, but it's worth noting what we're trying to find are the zeros when this crosses. So when you only have one solution, that's because it only touches once. It doesn't actually cross and then cross again. It actually hits that one, and that would be the vertex then. And then the other option is that you have no solutions. Here is a parabola that never crosses the x-axis, so it would have no solutions. So those are the three types. You can get a parabola with two solutions, one with one solution, or one with two imaginary solutions. It doesn't actually happen. Okay? So hopefully that's making sense. I'm going to back us up just a little bit. Okay. So remember I said that there's multiple ways to get a solution. And so this was just one way, and I'm going to show us another. So y equals x squared plus 5x plus 6. And we did the factoring method. We could have used the quadratic formula. If you remember the quadratic formula, that would be really useful here. So I'm going to actually show it to you. But if you do remember it, you can pause the video and try it out yourself. But of course, you've got 12 problems to try it out on, so no big deal there. Alright, so the quadratic formula, x equals. This is what x equals when y is 0. Okay? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Pretty neat. Quadratic formula. It's something that's worth memorizing. So if you have it memorized, it could make these problems much easier. You don't have to factor at all. You get the answer, what x equals, right off the bat. Okay? So remember, a is 1, b is 5, and c is 6. So we can do this. X equals negative b, negative 5, plus or minus the square root of b squared, 5 squared, minus 4 times a, which is 1, times c, which is 6, all over 2 times a, which is 1. Okay? You say, wow, that's looking horrible. But you know what? We already know it's going to simplify down to 2 very nice numbers. Okay? So x equals negative 5 plus or minus the square root 25 minus 4 times 1 times 6. What's 4 times 1? Well, that's just 4. Times 6, 24. Okay? 25 minus 24. 25 minus 24 is just 1. Divided by 2 times 1 is just 2. So it's already simplified down immensely. What is the square root of 1? What number times itself equals 1? And the answer is 1. 1 times 1 is 1. So this simplifies to negative 5 plus or minus 1 over 2. Negative 5 plus 1 is negative 4. divided by 2 is negative 2. Very good. Negative 5 minus 1, negative 6. Divided by 2, negative 3. And there we go. You get the two solutions. So you can get the two solutions either way. Okay. I don't know. I think most mathematicians would say that factoring is actually easier and it's more fun than the quadratic formula. But sometimes the quadratic formula is the best way to go. Okay? Alright. There is one more way to do this problem, and I think it's worth doing, so we will. But first, there is another way of figuring out whether or not you get two solutions, one solution, or no solutions. And it's in the quadratic, in this formula here, the quadratic formula. It's in here. In fact, if you notice down here, the square root of 1. The square root of 1 is actually positive. The 1 is positive. And so that's why it's real. If it had been a negative, we would have gotten I, an imaginary number. But we didn't. So since we got a real number, 1, we know that there must be two solutions. So this part is actually this guy here, which is actually this piece here, b squared minus 4ac. So if b squared minus 4ac is greater than 0, we get two solutions. That's guaranteed every time. So if all you're trying to do is figure out how many solutions you have, this is a great way to do it. What if b squared minus 4ac ends up being less than 0? Which would be a negative number. We get two imaginary numbers, two imaginary solutions. So no real solutions. Instead we get two imaginary. Solutions. Okay? And the last one, how can we get just one solution? Well, if b squared minus 4ac equals 0, that would just be gone, so it would be plus or minus nothing. The plus or minus would go away, and we'd be left with negative 5 over 2 as one answer. So, if b squared minus 4ac equals 0, then we get one real solution. And again, in our graph, that's the point at which the vertex, or the highest or lowest point in our parabola, is the one solution. Okay? So one real solution, two imaginary solutions, which is no real solution, and then two solutions. So those are the three options. So this is a way to figure out how many solutions you have. b squared minus 4ac is called the discriminant. Discriminant. The discriminant is b squared minus 4ac. b squared minus 4ac. Okay? That is called the discriminant. And that is how you can tell how many solutions you have. Real easy. b squared minus 4ac. Okay? And that tells you how many solutions you have. So this is something that you might want to write down. It's just a set of rules, really. They're rules for the discriminant and to tell how many solutions you have. Okay? So there is one more way to solve this problem. Remember, our solutions were -2 or -3. Okay? We can solve this using the complete the square method. Complete the square method. Okay? Alright. This is a simple problem because A is 1. If A was not 1, this would be a little bit more complicated. So, let's go ahead and complete the square on a simple problem. I recommend you try all of these different methods out on your problems that you've got. So try factoring each of them, try using the quadratic formula for each of them, and try completing the square for each of them. You should get the same answer every time. And so that'll be a good check to see if you're doing it right, because you get the same answer each time. And it's great practice. It's a lot more work doing 3 different actions on one problem, but it's worth it. Alright, so let's complete the square on this and see what we get. So, the first thing is to pull A out. Well, A is just 1, so we don't have to do that. The second thing is to pull the 6 out. So we rewrite this as y equals x squared plus 5x plus 6. So we need to give it some room here. So plus 5x plus something plus 6. Okay, so we need to figure out what this thing is. What thing do we need to put here? Okay? So remember, this is completing the square. So that's all we're doing here is doing complete the square. Alright, so we've got x squared plus 5x plus something, and then plus 6 outside of the parentheses. We're allowed to do this because we're just adding the 6 at the end anyway. Okay, so what number is b? So what we're going to do is we're going to take b, we're going to divide it by 2, and then we're going to square it. And that's pretty weird, but we have to do it. So every time, it doesn't matter what b is, we always take b, divide it by 2, and then square it. I always do it off to the side because it's a mess if you do it in the middle of the problem. So I always make myself a section for side work. I want to figure out what both of these are because we're going to use both of them in this problem. Okay, so b over 2. Well, we know b is 5. Not really simplifiable. I mean, we could turn it into a decimal, 2.5, but I don't think that would help us. 5 halves squared. Well, if you don't recall, I'll just help you out here. We need to square both the numerator and denominator. This is a distribution issue. We're distributing the square to the 5 and to the 2. So what is 5 squared? 25. And how about 2 squared? That's 4. So 25 fourths, and that is also not reducible because half of 25 is 12.5. So we could reduce it to 12.5 over 2, but then we have a number that's a decimal inside of a fraction, and that's not nice at all. So we don't want to do that. We're just going to leave it as 25 fourths. We'll leave this as 5 halves. Okay? So y equals x squared plus 5x plus 25 fourths. B over 2 squared. So b over 2 squared. And that's what we're putting in here. Plus 6. You say, wait a second. Can't do that. Well, whatever I do to one side of an equal sign, I must do to the other. So I added 25/4. So I can add 25/4 to the left-hand side of the equal sign. But adding it is the same as subtracting it from the other side. So actually, if I add 25/4 to this side of the equal sign, I could just subtract it as well. So I'm going to do that. I'm going to subtract it. Subtract 25/4. I'm going to do some side work here. I don't like 6. 6 has not got the same denominator as 25/4. So how many fourths does 6 equal? Wow. That was cute. How many fourths does 6 equal? Well, 6 times 4 is 24. 24 divided by 4 is 6. 24 fourths. 24 fourths. So I can rewrite 6 as 24 fourths. I'd give it its whole new line and write that, but I don't have an infinite amount of space here to do this problem, so I can't. Okay? So I'm going to do a couple of steps here on completing the square. So a number plus a number, x plus, so I'm actually square rooting x squared, and I get x. The square root of x squared is x, and then the square root of 25/4, well, we already know is 5 halves because we squared 5 halves to get that. So 5 halves squared. So that's the b over 2. The b over 2 goes right here in the complete the square. And then 24 minus 25 is minus 1/4. Okay? We're done. We have completed the square. That's it. Now, can we get -2 and -3 out of this? Well, let's find out. First, we're going to plug 0 in for y, because that's always been the case, that what we're really trying to find are the zeros. That means when y is 0, what does x equal? Okay, we're going to add 1/4 to both sides. And you say, wait a second, you could have just done that to begin with, subtracted 6 from both sides, and then we could have added 24/4 to, or added 25/4 to the other side, and the answer is yeah, you can. But I like this because this is in the form y equals a x minus h quantity squared plus k, which we'll get to. So it's in a special form. It's called the vertex form. So it's good to practice what you're going to want to do in the future anyway. Okay? So that's why we did it this way. It's just good practice. So I'm going to add 1/4 to both sides, getting us a 1/4 over here. And this 1/4 goes away, right? And now I'm going to square root both sides. And that leaves us with x plus 5 halves equals the square root of 1/4. Now, let's say it was a nicer number, like the square root of 4. I like the square root of 4 because it's just simple. We all know the answer. What number times itself equals 4? You said 2, you're absolutely right. But it's not the only number. What other number multiplied by itself equals 4? -2 times -2. So there's 2 answers to this solution. If you think about it, the absolute value of 2 is 2. What about the absolute value of x equals 2? So here's an equation, the absolute value of x equals 2. Remember, absolute value just asks the question, how far away from 0 are we? And you can only have a positive answer to that question. How far away from 0 is x? Well, it's 2 away. 2 away from 0. You say, wait a second, 0 is there. 2 away is 2, so x must equal 2. True. You say, whoa, negative 2 is also 2 away. That's right. X is 2 and or negative 2. They're both 2 away from 0. So really, a square root is really doing the same thing as an absolute value and a square root. Okay? So the square root of 1/4 is the square root of 1, which is 1, and the square root of 4, which is 2. The square root is doing, remember back here, the square was actually being distributed. We squared the 5 and we squared the 2. The same is true for square roots. We're square rooting the 1 and we're square rooting the 4. The square root of 1 is 1, the square root of 4 is 2. 1/2. You say, okay, we're done. No. Remember the absolute value. There's 2 solutions to a square root, just like there's 2 solutions to an absolute value. So we could put absolute values in, but we never do. We never do that. We just don't. Instead, what we do is we notice that there's always a plus and a minus. There's 2 solutions. Just like the quadratic formula, which had negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, it's plus or minus the square root. Plus or minus. Here's our plus or minus. Okay? So now, I didn't put the -3, -2 low enough. So we'll put it down here. It's out of our way. Okay. We're going to subtract 5/2 from both sides. And we're going to get our answer. Positive 1/2 minus 5/2 is negative 4/2. Negative 4 divided by 2 is negative 2. Negative 1/2 minus 5/2 is negative 6/2. And negative 6/2 divided by 2, negative 6 divided by 2 is negative 3. So we get the same 2 answers, negative 3 and negative 2. So you have a lot of options. Complete the square, quadratic formula, or factoring. Okay? Hopefully that all makes sense. There's a lot of weirdness going on with the complete the square, and I think a lot of students shy away from it. But I think if you follow the prescription here, which is to take your b and divide it by 2, write that down. Then square it, and write that down. Then plug it in, add it, and add it again, or subtract it from the same side. And then when you're going to turn it into a square, you use the b over 2, 5/2. Okay? So that's complete the square. Hopefully that's not something new to you. Hopefully that was just review. So remember, in each of the problems, there's 3 things that you're asked to do. Number 1, figure out how many solutions there are. Okay? The second thing is to figure out the solutions. And the third thing is to find out what the discriminant is. Okay? So we actually want to decide what the discriminant is. So in this case, it was b squared minus 4ac, so it's 5 squared minus 4 times 1 times 6, which became 24, and that was 25 minus 24, which was 1. So the discriminant, in this case, was 1. So we want to actually decide what the discriminant is. We also want to find the solutions and identify how many solutions there are. So in each problem you want to do those 3 things. There's other uses for the discriminant, so it's a good thing to practice figuring out what it is. it's great to find the zeros because that's something that we have to do throughout the year. And finding out how many solutions is always beneficial because, again, it's something that we're going to do pretty much all year. So it's worth being able to find.